Hey, hi everyone. Welcome to December's show of Scalable AI series. As you already know, Scalable AI series we have started early this year, and we have amazing sessions throughout the journey. And today we have a session which is quite interesting and one of my favorite. It's going to give an enterprise capability without changing the landscape or without burdening their existing system, Gen AI's flavor. And I would like to welcome Arpit and Alex for this show. Um,
Hi,
Here,
Manish.
Alex.
Hey, Manish.
So before I start, I just wanted to ask Arpit if you'd like to go over and again introduce yourself.
Yeah, thank you, Manish. Hi guys, I'm Arpit Gupta. I'm the CTO founder for MLAI Digital. We have been working on agentic AI for almost 2 years now, and Cosmos being a very integral part of the complete journey. We have understood the overall ideology behind how we can use Cosmos to make agentic AI more smarter and bring more ROI to the real use cases which we are trying to develop.
Thanks, Arpit. Alex, over to you.
Thank you, Manish. Great to be here. I'm Alex. I'm the CEO and founder of ADIOM. It's a San Francisco-based company where we specialize on migration and real-time replication of operational, productional database workloads. We work very closely with Microsoft, and we help customers to realize the value of their data anywhere. And a lot of times for GenAI workloads, it is Cosmos DB. So we help customers to bring their workloads there seamlessly with less risk and very, very efficiently.
Awesome. Thank you so much. In fact, if you are already watching my Scalable AI series, you would remember Arpit. He presented an amazing Gen AI story when we started early this year. So yeah, without much ado, let's deep dive into the solution. So Alex, over to you. Please take the stage and help us understand that solution.
Of course, just 1 second. Let me find the right button to share my screen. It's always exciting. So I'll show a couple of slides here. Some of them I will narrate, some of them Arpit, mostly about talking about the GenAI capabilities and their solution. And then we will show the actual demo, what things look like in the real world. So first of all, a few words about ADIOM's product Desync. Desync is really a data mobility platform for operational workloads and databases. What Desync does uniquely well is live database migration and replication from different databases to the same type or different type of database. And specifically here, we will be talking about DynamoDB, but we are not just working with DynamoDB. You can bring any data to Cosmos DB, whether it's relational, non-relational, S3, whatever you want. We can support from tens of gigabytes to hundreds of terabytes. And we do replication really well. It's predictable, and it's also as seamless as an execution of one command. What makes it possible is our unique architecture, where we decouple sources and destinations in terms of connectors, and we have unique module, which is a worker, and that is a unit of horizontal scalability. So the more workers you have, the faster things are going to work. And that also allows us to optimize connectors. For example, DynamoDB, Cosmos DB connectors are heavily optimized to support fast reads, transformations, fast writes. And our infrastructure allows us to provide features such as telemetry, resumability, observability, and yeah, a lot of exciting features. That's what I wanted to share here. We can support deployments as a single binary, and actually our single binary version is open source. It can be built from source, deployed as a binary, as a container. And we also have enterprise architecture, which is what I just showed you on the previous slide. It's multi-component. It's primarily targeted for enterprises' mission-critical use cases. And it can also be installed via Kubernetes. Of course, both offerings are available on Azure Marketplace. For this specific demo that Arpit and I are going to show you, we will use an insurance company, not a real one, a demo insurance company, which has an AWS deployment of a CRM database. It runs on AWS containers and uses DynamoDB as the underlying transactional database. There are several tables that I will show you in a moment, but for the point of this demo, we will show you how easy and seamless is the experience of taking the data from DynamoDB without making any changes whatsoever to the source deployment of the source application. We can bring the data and replicate it live to Cosmos DB on Azure and take advantage of a lot of features that Azure and Cosmos DB bring to the table. For example, for Cosmos DB, it's vector search, hybrid search, elastic capacity, and a lot of other interesting features at the AI layer. And those features will be realized primarily with products like MLAI, which is what Arpit will tell you about more in a minute. So Arpit, on to you.
Yeah, thanks, Alex. So maybe you can switch to the next slide. So yes, what we have developed is a insurance customer churn prediction product, where we have utilized a lot of agents, which is gonna understand the data of various customer profiles who have actually taken insurance policies from this insurance company. And on the basis of various policies which the customer has taken, we are trying to fetch that data and understand the prediction if that customer is going to retain with this insurance policy in the next year on the basis of cancellations which he had made previously, because the monthly premium which he was supposed to file, that is something which he has cancelled, or the customer has not replied to the insurance agent in the more happy manner, I would say. The sentiment overall was not very positive. So that customer data and policy data is something which we analyze. We use various agents which at the back end use a lot of ML based algorithms like random forest to understand the churn prediction. And then the last agent comes into place where we fabricate a personalized, hyper personalized email or WhatsApp message for the customer and throw him some discount. That is something which is we are trying to do as part of this activity. We have all the agents in place, communication agents also, and an MCP layer as well, which connects to the email server, and email is then sent to the customer. This is a flow diagram which we have got in place. The left side, you can see the ADIOM product, and then we have MLAI's product where we have multiple agents. Okay, I forgot to tell you about the agent one, which is a RAG-based chatbot, where we can talk to the chatbot, and the customer can probably, the insurance agent can actually talk to the chatbot and can get all the details, which details are like, let's say if he's trying to inquire about customers who might churn and have got a salary of more than 90K per annum, they're based out of California. Like that, he can put those questions and he can see a list, which obviously we're going to show it in the demo. Yeah, so that's about the product. It has more features, but yes, in interest of time, we would like to show you most of the common features, I would say.
Of course, and we will actually show what it looks like in a moment. Let me transition to the video. Oops. Just 1 second. Let me find the right one. Okay, here is our CRM database in DynamoDB. It has 6 different tables. Each table has some millions of records, something between 10 to 15, and some gigabytes of data. So it's not a trivial example. Here you can see that we have our CRM UI that allows us to view different tabs, edit them, edit different objects, specifically agents, customers, claims, documents, policies, transactions. And here is our destination Cosmos DB database, which is empty right now. I'm going to show you our new experience, which is really, really cool. It's an agentic-driven experience where instead of putting all the parameters manually into the system for the migration, which is the source, which is the destination, what to migrate, we just give the migration agent a prompt and let the migration agent figure out what needs to be done and how. So let's see what that looks like. Here we start our agent, and we will give this migration agent a task where we want to migrate insurance application data from DynamoDB to Cosmos NoSQL. The only thing I did in the background, I created some environment variables that give the credentials for Cosmos DB and DynamoDB. You can see these here. And now the agent will figure out what needs to be done. It will take a few seconds. Here, it will first analyze the data. It will validate that it needs to create the containers on the Cosmos DB destination. And then it will ask us if we want to start the migration, to which the answer is yes. Behind the scenes, it will start the desync with all the right parameters and the right level of parallelization to kick off the job. Here, we can see the web progress, and there's a nice progress bar. You can see the breakdown by different table, how far ahead we are. We can project how much time it's going to take. In this case, it takes just under 10 minutes to copy the whole data set. And then after copying the whole data set, desync automatically switches to the change data capture, where it establishes a real-time data sync. And that would mean for us that we, as a user, don't need to do anything at all. We just sit back, relax, and let desync do its job. In this case, it will take a couple more seconds. And I'll just scroll here. Here we have our change stream. So at this time, desync is still running, and it runs in the change data capture mode. If any changes are made on the source, it will be seen in the destination. You can see in the Cosmos DB, now we have the data. It's the same exact data as in Dynamo, but now we have a real-time sync. If we change something in the Dynamo side, it will be changed on the destination. One thing we will do is we will go back to the agent and we'll tell it that we are done with the initial sync, and it will prompt us to try and create the indexes on Cosmos DB because we have not done this. Since we will probably want to use some indexes to support our queries on Cosmos DB, we will let the agent do that. And after doing that, the agent will probably consider the migration done and will happily exit. But the desync will just keep running in the background, so we can keep doing changes in DynamoDB, and they will be reflected in Cosmos. So, for example, we can create a new claim. We can enter it some details, click submit, and then we will be able to find this claim in Cosmos DB when we go to claims and enter a query, put the ID of the claim that we just created. There we go. It's right here in Cosmos DB in real time. And for the purposes of this demo, what we will actually do, since this was a recording, we will break the fourth wall, and we will go and create some additional records in real time that Arpit will be able to demonstrate to you in his solution. So let me go back here. And here is this very same CRM that we just used. And we are going to create a customer with a very specific ID. So Arpit, please note, that's the one that ends at 718. I'll send it to you offline too. And it's not a remarkable customer. It has an unknown customer for first and last name. So we will create that. And for this customer, we will also create a policy. And it will be a health policy. And it will have a certain coverage amount, a deductible, and it will also be created as canceled. So we'll do that. And that's it. So I'm not going to go and show this in Cosmos DB. We will see the data actually in Arpit's solution all the way. So I'll transition to Arpit here.
Yeah, thanks, Alex. So generally this transition doesn't take much of a time. So I guess it should be there in our system. I'll share my screen. Okay, thanks, Alex. I can see the customer is there with us. And as you said, he's not a very good customer. We can see that cancellation rate is almost 100%. Customer tenure was 218 months, almost like uh, I would say 20 years kind of a thing. We can see that what kind of a policy he has. So the policy is cancelled. Payment frequency was annual. So in the live environment, we can see the customer and his corresponding policy has come to this portal, and we have a communication agent, as I said, which generates a hyper personalized email or WhatsApp message, I can say, but we are showing the general email content which we are trying to get for this customer. So we are trying to offer her a special loyalty discount because the customer is not very friendly to this brand. And if we need to edit, we have options to edit this email. Otherwise, we can just send this email to the customer so that he gets attracted towards the loyalty discount what we're trying to throw, and the customer can get easily onboarded with this brand again. So this is the I would say a working of the agent, the communication agent, what we have developed, which is trying to hyper personalized, curate a message for a particular customer and show it on a dashboard and send it to the end customer through an MCP server. So yeah, Alex, we can see the flow and it's working perfectly fine. Thank you for that. Yeah, so the complete product, which is visible on the screen, how it acts is it's a live product with a insurance company in Asia. So what we're trying to do here is that an insurance agent who is, let's say, risk assessment agent, he comes to office, he tries to log into this dashboard, and there is a chat agent. He says that, okay, I want a list of customers whose income is more than 90K and is based out of California, or let's say any region particularly. But we're trying to show you a search which is trying to query using semantic search and hybrid search. He's trying to query a RAG model is also there at the back end, and we are using GPT-5, and we are trying to get the results for 20 customers. So let's say we have got 20 customers with the name, occupation, income, credit score, similarity scores, everything is coming. We have an option at the end to download the report as well, so that he can analyze the customer one by one and try to see that how the results are popping up. So this is the search result report which he can get. This is something which is again coming from Cosmos. We are leveraging both semantic search and hybrid search, as I said, for getting the complete response which is coming through this chat agent. Okay, then at the next step, we can pick any of the customer from here. Okay, and I can go back to the customer analysis side and analyze the customer. There is a historical data which comes in. Let me check. Yeah, so this customer, you can see that it has overall churn risk as high. We have customer profile as well with email ID and annual income, so that let's say if the communication agent has to send an email, that can also be generated and can be sent to this particular email ID. the customer would get apprised of various offers or various other details which might come in. So this is the overall job of this product. The overall idea is to make the insurance agent understand if a customer is trying to run away from the brand, and if he is, then what are the steps how we can try to uh, lure the customer to stick to the brand. We can send discounts, offers, or maybe some other goodies in addition to the overall product. So that's what we are trying to do. And as I said, like Cosmos is something which is an integral part. The data is coming through a super app to AWS DynamoDB first, and then it is moving to Cosmos. And then we are trying to leverage the overall GenAI part in terms of identifying the customer churn. Yeah, Manish.
Superb. Thank you so much, Arpit and Alex. It was a nice demo. I have few questions I want to ask. So starting from Arpit, because your screen is already there, so I wanted to ask you a few questions on your part of the solution. So what are the pre-processing and semantic enrichment or vectorization steps do you consider essential before feeding Cosmos TV into generative AI models?
So I think is one important is like a filtration process, which is again done by one of our scripts. You can say maybe an agent who's trying to filter out some of the data and try to check the customer and its policy. Coming back to the vectorization part, we have something where we are trying to analyze, see what kind of to do with that data, searches which we are trying to do, and then pop it up on the screen. So these are the two major areas which we are trying to do as part of the complete Cosmos integration. And vectorization, as I said, I'll repeat myself that vectorization is an important part where we are trying to querying for a particular, I would say, prompt or a question.
Got it. And about model selection, so how do you decide between fine-tuning foundation model versus building domain-specific agents, given the nature of your data getting replicated?
Okay, good question, because we see this coming to us on a daily basis from various financial services domain. Output which is coming from the, how much we can try to fine tune it. Or let's say in some cases we might have to add extra information. So there is some result which is coming up from LLM/GPT, but we might have to add extra information that might come from any other MCP server. So in that case, fine tuning comes into place. We might have to add extra messages or message content altogether. That is when where we are using a lot of fine tuning. Otherwise, we go by standard models, which becomes easier for us to get the results in a quick frame of time.
Super. And about the business outcomes, what framework do you measure whether a generative AI application truly delivers ROI or competitive differentiation for the customers? I think it's very
Yeah,
important. Yeah.
exactly, 100%. We are seeing, like you would have seen on LinkedIn and other social media channels, that people are posting that GenAI is not able to bring ROI. So we generally measure it by two factors. One is either the sales, or maybe you can say the overall revenue increases for a customer. Okay, top line is something which is getting increased by using these products. The customer stickiness comes in, and then we see the revenue going high. And second is if we are able to maybe like uh, save some human efforts by using such tools. So let's say if I, as I showed it to you, the customer can put up a query and he can get like all the customers who have got salary more than 90K. That helps the overall agenda in terms of getting the data in a quick period of time. He doesn't have to really go in an Excel or maybe find out in a CRM who all are the customers who can maybe run away from our brand. So that is something which we try to automate. We try to save manual efforts so that the monotonous job can be automated.
Super. And because you're in financial domain and most of your customers are coming from FSI space, I'm sure this question is certainly relevant for you in this industry. And in fact, a lot of other industry I can see that is also coming up with very strict ethics and governance standpoint. So how do you embed safeguard around bias, hallucination, compliances when deploying generative AI applications powered by Cosmos DB data?
Yeah, so compliance is very important thing for FSIs. So we make use of all responsible AI mechanisms which are provided by Microsoft, and our team is totally trained on in terms of using those guidelines. Then we have other compliances in terms of most of the financial services. They have got LLMs approved by their IAC, means their security group. So we can always try to leverage those LLMs and make use of those LLMs in this kind of a product. Third is this product generally works on a environment where we have Microsoft Entra ID into place, so that only subscribed users or maybe authorized users can only use this product. Then we have options like you cannot take screenshots, we cannot take other compliances which are very general in terms of various financial services.
Super. I just wanted to highlight, actually, we have, for my audience, actually, we already have a lot of, detailed insights with the, compliances and security standpoint. We have published a security baseline, and that baseline is right now already public. So if you wish to fine tune your Cosmos DB implementation, you can easily do that without any challenge. And you can follow through that guidelines. I'll ensure that as part of this video, I'll also share on the either comment box or description, whichever is easier to search that link to baseline of security. So thanks, Arpit, for answering those questions. Now over to Alex. Alex, I have a few questions from you.
Of course, fire away.
Awesome. So I want to ask you one question around the scalability and the architecture, because your solution deals with the heterogeneous system, and it is basically coming up with a lot of data, a lot of volume. So what architectural choices have you made to ensure replication pipelines into Cosmos DB and it scales seamlessly across millions of records without any bottleneck?
Excellent question. This deliberate choice of architecture, of how we build it, is frankly the reason for building Desync and maybe even starting ADIOM, because I firmly believe that the architecture defines our capabilities, and we wanted to make this platform not just easy to use, but also scalable and also transferable to many different data sources and destinations. So what allows us to do this is primarily decoupling control flow from the data flow. For the data plane, we have a zero storage streaming architecture. Unlike traditional ETL tools that just dump data to a staging bucket, S3, blob storage before loading, Desync streams data directly from the source to destination in memory. This eliminates disk I/O bottlenecks and creates immediate throughput. We can also optimize each connector, like we optimize connector for Dynamo and Cosmos, independently, so each of them can do the best they can do for that particular data source. And sometimes those things are different. The way we do fast reads from Dynamo is very different from the way we do fast reads from Cosmos. The same goes for writes. And to be able to handle very large, like sometimes we handle like hundreds of terabytes volumes of data. Instead of monolithic process, we use intelligent partitioning. We use those strategies specific, like I said, to each data source to break down the data set into relatively small tasks, whether like physical partitions or something else, and that can be executed in parallel. And that works really well in this massively horizontally scalable platform, but it also works surprisingly well and it's just a single binary. That really what allows us to achieve very high scalability, but also very high reliability. And lastly, this reliability, it has a very important quality. It allows us to be resumable. Whether we are in the initial sync, imagine taking 12 hours to move 100 terabyte of data, right? You don't want to break everything and restart every time something fails, right? It's just expensive also. So we can restart or resume, I should say, from any point in time during the initial sync or the change data capture. And it's a very common concern for many of our large enterprise customers.
Very nice. Thanks. What about the quality and consistency? I think it's very important, and ensuring the correct handling of schema drift, conflicting formats, real-time consistencies when ingesting data from multiple heterogeneous system. How do you do that?
Well, I should say that data consistency is probably the hardest part of distributed systems. And the way we handle it at actually two layers: type adaptation and CDC orchestration. For schema drift specifically, we use a dynamic type system. Since originally, from the very beginning, we were focused primarily on NoSQL to NoSQL, for example, like Dynamo to Cosmos DB, we never had to, and we still don't, and not planning to enforce a rigid schema on the pipeline. So if a source field, let's say in DynamoDB, changes from integer to string, we just capture the change in the BSON or JSON document structure and propagate it, but we don't require changing the schema of the pipeline, restarting anything. The user doesn't need to do anything, doesn't even know about it. But we also support embedded transformations where a user can define rules. For example, if they want to change the type on the fly, or if something is null, they want to convert it. So they have this ability to define their transformation rules in the YAML language. For data consistency, we use a blend of initial sync and CDC, not as a two separate phases, but more like a continuous timeline. You can call it a snapshot and catch-up model when we initially take and transfer the snapshot of the source to the destination, and then we track the offset for incoming changes from the beginning of the snapshot copy. So that when snapshot is done, we just replay the changes starting from the initial offset, and that's how we make sure that assuming all the operations are idempotent, which is what we do, we know that we can get to a consistent point in time on the destination. And we also support, naturally, since we work with enterprises, a range of data validation mechanisms, things like a full data hash, spot checks, random tree-based approaches. They all have different balance between performance and consistency. So depending on the specific customer requirement, we always work with them to select what makes the most sense.
Awesome. And next question is about cost and performance data, which is quite harder. But I wanted to understand from you. So what strategies do you use to balance replication speed, throughput, and cost efficiency in Cosmos DB setup?
Mm-hmm. Specifically for Cosmos DB, it's very interesting because one of the biggest advantages, at least from my perspective, of Cosmos DB is elastic scalability. But when we use autoscale, Cosmos DB charges for request units. So while desync can have blazing fast or enable blazing fast migration and replication, that can also mean expensive migration and replication. So for that reason, we do give users a control knob for concurrency, and they can cap the number of concurrent writers. And if, let's say, a user is doing a backfill and cost is a concern, they can just throttle this number of writers so they can stay within their auto-scale baseline. And if speed is critical, for example, it can become critical during a cutover window, then the user can uncap the number of writers and just max out the partition throughput all the way to like 10,000 RUs per partition, which is, I think, is the max on Cosmos DB. Crucially, we also use bulk API for writing to Cosmos, and we optimize write amplification. So we try to batch intelligently and efficiently all the changes. So if there were multiple changes for the same record, we compact that and only apply those that are the most latest whenever it's safe. The other thing is we try to work really well with multi-region deployments for Cosmos DB, and our experience there is just to focus on writing to one region and just let Cosmos DB native global replication handle the geo distribution itself. That makes it everything easier. Cosmos DB does a great job at it, very transparent. There could also be some additional efficiencies there. Cosmos supports a dynamic scaling feature. We haven't played with it yet, but because it allows different regions to scale independently, there could be some benefits from that. And the last optimization that we generally recommend to max out performance of large-scale replication tasks is disabling indexes. You disable them before the bulk load. Like you saw in the demo, we actually were guided by this migration agent to start the migration job without the indexes, and then you create it later during the CDC stage. Cosmos DB supports asynchronous index creation. It just submits a job to create indexes, and you just wait for them to get created. And not having indexes, in my experience, adds about 100 to 150 effective throughput in terms of RU capacity.
Agreed. I think these are various optimization practices you have outlined in Flow. I think it's very important, and when you're dealing with the scalable systems like Cosmos DB, because the cost is directly proportionate to how much TPS you need, and fine-tuning your TPS according to your requirement, it actually balances both cost and performance. And you rightly mentioned about the dynamic scale. This is a new change we actually brought on the table. That's going to be not impacting anything on the technology side, but it is impacting on the billing side, where previously we used to have a normalized RUs calculation, but now we are basically picking up RU for each partition, whether it is remote partition or local partition, and that's how. And then we sum it up, and that's how we are able to reduce the cost in overall perspective without anyone does anything. And it is going to help in certain scenario where you have more load in specific partitions and less load in other partitions. So that ways your cost is not going to be like a multiplication factor. It is going to be like whatever you're consuming, you're getting charged for it. Yeah, great observation. Thanks, Alex. And the last question is around future proofing and extensibility, because I'm sure as soon as you're going to other customers, and various customers will have various different needs. So how does system adopt for like design replication framework and to new data sources, specifically compliance requirement and additional emerging AI workloads if come across to your pay? How does it handle those changes?
Great question, Manish. One of our earliest design decisions was to try and accommodate enterprise workloads. And that is hard because every enterprise, and I'm sure both you and Arpit have seen many times over, every enterprise is like a snowflake. They have lots of different edge cases that are specific only to them. So there are lots of similarities with a lot of others, but there is always like a couple of things that are unique. And we tried really hard, and I think we are very successful at this, is making sure that all of those specifics can be accommodated within a very simple and predictable timeline and framework that we developed. So we effectively future-proofed our architecture by adopting what I can describe as a plugin-based architecture via gRPC, which is Google's RPC method. In effect, the core engine of desync, it does not actually know what a database is. It just speaks a particular protocol. It's more sophisticated, but imagine like read, stream, write. And the connectors, sources, and destinations, they're just separate entities. Like they could even be separate binaries altogether deployed somewhere remotely that communicate with the core over gRPC. And they announce their capabilities, and the core figures out how to bridge those things together in the most efficient way, similar to how networking protocols work. But in a nutshell, that's really what it is. And that also means if a new vector database for AI emerges tomorrow, or a niche legacy system needs support, we, or maybe our community, just write a small gRPC wrapper for that particular source. We don't have to rewrite the core application logic, retry mechanisms, observability, or concurrency handling. All of that stays the same. And for AI workloads specifically, this extensibility allows us to inject complicated transformation steps. For example, generation of embeddings on the fly, or offloading things to S3, PII masking via an LLM call. We can inject all of that right into the pipeline before the data ever hits Cosmos DB. And this is what allows us to turn this replication pipeline and desync as a replication tool into a lightweight AI ingestion engine.
Awesome. Very nice. And one last question I wanted to ask Arpit on the future roadmap of his solution. So, Arpit, what is in the future we have? What
Yeah.
changes?
Okay. So I think, honestly speaking, Manish, GenAI, agentic AI can transform agentic AI insurance industry as well as capital markets to an extensive level. Okay, that's what we have realized after working with almost 30 enterprise customers. So we have a lot of features which are coming up in this product, especially on the security side, especially on the I would say like more features in terms of GenAI, agentic AI. All those things are coming up in this product. We want to understand the overall charisma of GenAI, how it can transform this customer churn prediction methodology. That is something which we are trying to do as part of next phases. We already have a lot of phases which are coming up. We have next two phases already decided what all new features we gonna incorporate to make this a better product.
Awesome. Thank you so much to both of you asking questions. Sorry, answering questions candidly. It was really an amazing talk. Thank you so much. Lovely to host you, Arpit and Alex. It was great to hear about this solution. And to everyone, if you have any questions to ask me, Arpit, or Alex, please put that in the comment box and we'll be happy to answer this question. Thank you so much, guys.
Thank you, Manish.
Hey guys, if you have not submitted your question, feel free to submit. We'll be happy to take up those questions. One other question, I think from the submission, already submitted question is that how do you harden Cosmos DB from DDoS attacks? So the answer is Cosmos DB supports private endpoint. Also, it supports a network perimeter. So what you can do, you can configure your private network using virtual network functionality, and Inside that, you can remove the public access, and then you can make your database more secure. Apart from that, there are many other possibilities we have. Um, we have a article called Security Baseline of Cosmos DB. If you search, you will find that article, and definitely follow through those best practices of network configurations. Uh, Another question is that how do I connect my existing systems to Cosmos DB if they are on different virtual network? How they do connect, securely? So you can use VPN, site-to-site and point-to-site VPN, or express route connectivity. Um, if you want to connect both the virtual networks, you can use um, VPN or VNet peering also. So those are pretty standard Azure functionalities which you can configure to connect to Cosmos DB's virtual network. Apart from that, you can ensure that your data is completely isolated. So those are certainly possible. We do support uh, Cosmos DB, CMK, and other encryption methodologies so that your data is completely secure. Okay, another question on how do I identify the performance? So we have monitoring already there. So what you can do, you can keep monitoring the data, and uh, there are charts. We call it Azure Cosmos DB Insights. If Insights is not good enough, you can go to metrics and you can choose the specific metrics, number of total requests, number of total request units. Those are important metrics to keep a track on what is the usage going on and how many number of requests are being performed into the system. Okay, with that, thank you so much for watching this episode of Scalable AI. Next month, we'll see you on 29th of January, 8:30 a.m. PST, which is actually 10 p.m. IST. And we'll see you then. Thank you so much. By the way, if you haven't posted your question, please do that. I'll be happy to take up those questions in the next episode of Azure Cosmos DB Scalable AI series. Thank you so much.